So, you've probably heard me mention the unit circle quite a few times, and now we're finally going to look at it. So, this on the right-hand side is a picture of the unit circle. So, it's a circle that's centered at 0, so we're centered at the origin, and it has a radius of 1. So, anywhere that we draw a line from the origin to the outside of the circle will have a distance of 1. Now what we want to do is to imagine a point that's on the outside of the circle. So let's say I put a point about right there. So this point is on the circle, specifically on the unit circle, and it has some coordinate x, y. What it also has is an angle measurement. So if I drew a line out to that point, what we have is this angle measurement here coming from standard position. And these angle measurements, they'll be going in a counterclockwise direction. So this will be positive when we make this measurement here. So what we want to be able to do is evaluate these points in their relationship with the angles. And that's going to end up tying to sine and cosine. Now what we're going to focus on in making our unit circle are those angles, 30s, and increments of 30s and 45s, what we've been practicing so far, so that we can generate those from memory and without a calculator, without having to refer to the unit circle each time. Our unit circle is going to give us a basis for this knowledge, and then I'll show you how to draw it from memory. So with this, I have a little simulation to see how we're going to move this point around, because we want to use all sorts of different angle measurements, which is going to lead to all sorts of different coordinates. But the idea is that getting these coordinates out for x and y are restricted to landing on this specific circle. Now we could already map 4 of the points. We could map this coordinate, this coordinate, this, and this fairly easily, because it's just going to be a relationship of 0, 1. Like this is 1, 0, this is 0, 1, this is negative 1, 0. So we'll see some negative numbers coming up with these. This is 0, negative 1. But what we want to be able to do is map the values that are in between those input and output values. So just to show you demonstration, it's this idea that we can move this around, and t is in, sorry, let me get t to be positive. Here we go. So t is in radians, and then you can see it's mapping the coordinate. So for here, about here, close enough. We would be at about, pi over 2. There we go. Yeah, about pi over 2 would bring us there, like we saw in our last week of videos. And then if I got close to pi, let's see, 3 and a little bit, yeah, almost there, then we're at about that negative 1, 0 point that we're seeing. So as we move around, we're going to have these angle measurements, and we'll measure in both degrees and radians. So we're going to start switching more to radians. And with that will be this coordinate that's along this unit circle here. All right, so before we start mapping the entire circle, I think it's really helpful to just focus on the first quadrant. Because really, if we have the first quadrant, the rest follows through just because of symmetry. We have these same y values, it's just and same x values. It's all a matter of reflecting over the y-axis and over the x-axis and changing negative values and positive values. So we're going to see is this collection of it's just a few numbers that make up this entire circle of numbers. So let's just start with the angle measurements here. Since we practiced those angle measurements last week. So here we're at 0 degrees. Here we're at 90 degrees. Half of that would be that 45 right there. And then our other increment is 30s. So we have 30, 60, 90. Now we have our radians as well. So this would be 0. This is pi over 2. And then we have at 45 degrees, that was the same as pi over 4. At 30 degrees, that was our pi over 6. And at 60 degrees, that was our pi over 3. Or you could think of that as 2 pi over 6, but it reduced down to that pi over 3. So those are the key angle measurements that we talked about. What I showed up above, we already know we know all of these coordinates, but just to get the ones and zeros done, this would be 1, 0, and this would be 0, 1. Now, these coordinates we can find based on those special triangles. So if we focus on this 30-degree angle here, what I can do is imagine that right triangle. And it's just a matter of thinking, okay, what is x and what is y? And this is occurring when we have these 30 degrees right here. So we can see as x is that long side, so that would be the root 3 over 2. And y, moving vertically, is the short side, and that would be 1/2. So we get those two coordinates just thinking about that special triangle. Then we would have, I'm going to erase that piece, we would have our 45, 45. So our side lengths were the same there, so that root 2 over 2, root 2 over 2, and those would be the two coordinates. And then our last one is the 60 degree. So we would have our short side for x, long side for y, which would mean we would have 1/2 for x, root 3 over, let me rewrite that, over 2 for y. So with that, we can fill in these numbers, we have those angle measurements, and then using those two triangles, we can fill in those numbers. Now, some memorization techniques with these, I draw the triangles a lot, that's what I go to, and then just keeping in mind that short versus long side for the 30 and 60 degrees. Something that's nice is that all of these have a denominator of 2, so if you're unsure of what goes in the denominator, it's 2, it's always 2. Then there are some nice kind of patterns that show up here. So I'll end up erasing these, but let's say at 1, we even had a square root over it, which square root of 1 is just equal to 1. So what you can notice is for the x coordinates, we start at 1 and go down to 0. And then what you could do is you can always fill in the denominators of 2. Then you could think of this as kind of counting down. And with that, we start at square root of 3, then go to square root of 2, then square root of 1. And then y does the opposite, or you could think of it as going that direction, counting down, or you could think of it as counting up from 0 to 1. So we'd have 0, 1, 2, 3, until we get to that value of 1. And there are so many other techniques of memorization, but those are some that I think of. I really go to the triangles each time, but there are those patterns of kind of counting from 0 to 3 in there as well, which is nice. All right, so what we looked at in that last video, let's go ahead and look at our 30 degrees. What we saw in the last video was sine of 30 degrees and cosine of 60 degrees. 30 degrees. Let's look at both of those. What we found is sine of 30 degrees was 1/2. Cosine of 30 degrees was root 3 over 2. Well, what we could see is relating that to what we're seeing for our coordinates is our cosine value is showing up as the x coordinate, sine value is showing up as the y coordinate. Let's look at 60 degrees. What we found in that video was sine of 60 degrees was root 3 over 2. Cosine of 60 degrees was 1/2. So what we see here is that sine value showing up as the y coordinate, cosine value showing up as the x-coordinate. Now I'm skipping over 45 degrees here because they're the same, so it's hard to see that distinction, but it's the same relationship. So with both of these, sine is relating to y, cosine x. Sine is relating to y, cosine is relating to x. And that's a relationship across our entire unit circle. And it's what we're going to refer to so that if we need to evaluate sine and cosine for these angle measurements that are increments of 45 or 30, we can find them as coordinates on the unit circle. So the relationship goes for sine, that is our y-coordinate. So if we need sine value, we're just looking at those y-coordinates that are showing up as we go across that first quadrant of the unit circle. For cosine, it's the x-coordinates. So grabbing those x-coordinates as we go along the outside of the unit circle for these specific values that we're finding. So mapping coordinates on the outside gives us all of these cosine and sine values for these specific angles. And that's where the unit circle is so valuable, is that if I know I'm at 30 degrees or any increment of 30 degrees, by finding that coordinate, I can make substitutions for cosine and sine by referring to that coordinate. All right, in the next video, we're going to fill in the rest of the unit circle, but it really all starts here. So if at any time you get overwhelmed by this idea of memorizing all of these numbers across the whole circle, zoom into that first quadrant because that's where it all begins.